Johnston.
Liz Boackle.
Cameron Roberts.
Callie Peak.
It is crucial to scan across all wavelengths in order to determine the absorption spectrum of a substance. The lambda max refers to the wavelength at which a substance absorbs light most strongly. By scanning across a broad range of wavelengths, you can identify the point where absorption is highest, which corresponds to the lambda max. This wavelength is particularly useful in identifying the substance and understanding its properties, such as electronic or vibrational transitions. It is also crucial to scan across all wavelengths in order to characterize emission from fluorescent materials. The lambda max in the emission spectrum refers to the length at which the fluorescence intensity is highest. By scanning across all possible emission wavelengths after excitation, you can pinpoint this peak. Knowing the lambda max is crucial for applications in imaging, diagnostics, and sensor design, as it tells you the best wavelength to use for detection or measurement. Whether for absorption or emission, the lambda max is a crucial feature that defines the wavelength at which a substance exhibits its strongest interactions with light, providing insight into its structure and behavior. The Beer-Lambert law is a fundamental principle in spectroscopy that describes the relationship between the concentration of a solute in a solution and the absorption of light at a particular wavelength. It is often used to determine the concentration of substances in solution by measuring the absorbance of light at their lambda max.
Okay, so right now we're just transferring the solutions that we have gathered into our cuvettes. Okay, so first off, we are going to take our paper and we're going to clean the two sides of the cuvette that the light's going to be passing through. And this is our blank. Okay. Now we are going to open, place this in here, and then close. Now what do we do?
0.
And we click 0. And it's successfully zeroed. And now we are going to open her back up, grab our cuvette, and close it. Alright, so now we go and we find the peak, and then we come up over here to our chart of absorbances and we find the highest one, which would be our peak. And then now we are just going to X out of this and clean up our area. So this goes in the trash, and then we will dispose of these as proper. We're disposing of our liquids in the hazardous waste containers. With water.
This is gonna be time lapse.
And then we put that where they came from. Cute.
Yay!
Notice how we're the first. And now we're gonna dry them off.
Yeah.